a network attack surface. Okay, so this is related to the network protocol vulnerabilities. So for example, if you open a port on your firewall, then you are allowed outside traffic to come into your system, then we can consider you increase the attack surface. Okay, so once you shut down the ports which are not uh, uh, used, then we can think you decrease the attack services. So then, for example, in some network protocol, you enable the security mechanism, then you decrease the service, or you enable more functions. And because these functions may be vulnerable, then you can consider you increase the attack service. Okay, so you may be able to guess the concept of the attack service. All the things which may be vulnerable and exploitable are considered as attack services. Okay. So next is the software attack surface. So all the vulnerabilities in application, utility, or operating system code are considered as attack surfaces. For example, you create a website, then initially it does not have the search function. Then later on you add a search function. Then attacker may be able to use this search function to attack your SQL database or attack your code. Then we can consider this search function actually increase the attack surface of this website. Okay, and this search function may be used to launch SQL injection attack because you need to accept the input from the user, and you may try to search the database based on the input. Okay, and next is the human attack surface. For example, we hire a new employee. Then this employee is allowed to access some critical data. Now we can consider um, this employee increase the human attack surface because this employee may suffer from the social engineering attack, may leak the critical data. Okay, so this is the concept of the attack surface. So why is this important and useful? Because we can know how vulnerable one system, software, or network component is based on the analysis of the attack surface. Okay. So here is the analysis of the attack surface versus security layering. Okay. So when we have the large attack surface, even if we have a deep layering means we have several security mechanisms in a row. For example, we have the security mechanism at the gateway, and in your Wi-Fi router, and we have another defense in your personal computer. Okay, so in this case, we have 3 layers of the security mechanism. So more deeper the security layering is, the more secure the system is. Okay, so we prefer to deploy the deeper security mechanisms. Okay, so even if we have the large, even if we have a deep layering with the large attack surface, we can we still have the medium security risk. So given a system or software, we always want to minimize attack surface. This means we always want to disable the functions we are not used because they may be vulnerable, but actually they do not provide any functionality. And moreover, we also want to provide the deep layering, okay, so that we can achieve the low security risk. Okay, so we want to prevent large attack surface and shadow this security layering, because this will lead to the high security risk. Okay. Okay, and we may also use the an attack tree to analyze the one system. Okay, so here you can see in this tree, actually the root represent the attack goal. Okay, so here in this example, the attack goal is to open the safe. Okay, because safe we have we have a facility or box to store some valuable things or uh, components, okay, or cache. Okay, and leaves represent different ways to initiate an attack. Okay, so for example here, threaten, okay, or blackmail. Okay, so these leaves represent different ways to initiate an attack. And each node is either an end node or an OR node. Okay, so here for this, actually this is an end node. Okay, and this is an end node. Oh, sorry, this is an OR node. Okay, because these attack can be achieved by either this one or this one. Okay, and this attack can be achieved by both the combination of these two attacks. Okay, so let's try to trace this attack tree from the top. So here the goal is try to open safe. So how to open safe? Actually, we can list all the uh, possible attacks and to think about whether they are feasible. Actually, this is how you think about whether one system is vulnerable or not. Okay, and the first one, pick lock. Pick means we try to use the small tool. This is like this picture. Okay, so we use several small tools try to open the lock. Okay, so here since nowadays the lock is very secure for the safe, then I represent the impossible. Okay, so this way is not possible to achieve it. Okay, and the second one is to learn combo. Okay, try to learn the security code which can use to open the safe. Okay, so it is possible. Then how to learn the combo? Actually, there are two ways. The first way is to find written combo. This means maybe the owner may write down the combo code on a paper, but actually now uh, the owner do not do it after understanding this owner. Okay, so this is impossible. Okay, and another way is to get combo from target. Okay, then it is possible from the owner. Okay, from the owner himself. Maybe the combo code can be spoken out by the owner. Okay, so it is possible. And the first one, we may try to threaten the owner. Okay, but this is impossible. We may try to use the blackmail. Blackmail means we hold something valuable to the owner, then threaten the owner to speak out something or do something. Okay, so this is called blackmail. And based on the understanding of the owner, actually this is impossible. And the third, eavesdrop. We may try to eavesdrop on the trade between owner and other people. Okay, but this is impossible because if we want to eavesdrop on the trade, then on the trade to learn the combo, actually we need to listen to conversation. Okay, this is possible, but it may be impossible to get the target to speak out the combo code. Okay, so this is impossible. So based on the end of these two, so we can conclude that it is impossible to use the events dropping to get the combo code. And the last way to get the combo from target is to bribe. We may try to use the social engineering attack, try to give out money, for example, give the money to the secretary, who may know the combo code. Okay, so in this way, it is possible. Okay, and the next, okay, we try to go to the next in this level, or we may be able to try to cut the open safe. We may try to steal the safe. Okay, try to move the safe to a security place. Then we try to cut the safe. Okay, this is possible. And the last one is try to the safe may be installed improperly, so we may be able to easily open the safe due to this improper installation, and this is impossible. Okay, so to conclude, the security of this the safe open, then actually there are two possible ways to attack the safe. One is cut the open safe. The other is to bribe uh, the target to give out the combo code. Okay. Okay, so this is just one example to let you know how to construct the attack tree to do the analysis on one attack goal. Okay, then based on this attack goal, then we can understand that how we can secure the safe. For example, we need to prevent attackers from cutting the safe. We may try to hire, we may try to keep the combo code safe. Okay, just keep the combo code to the owner is himself. We should not release the combo code to some other people, for example, the secretary. Okay. Okay. Yeah, so we already talked about why our attack tree is needed because we can analyze the security vulnerabilities of a target system. Okay, so this is another attack tree, more complicated attack tree. Okay. So here we consider an internet banking authentication application. Okay, so the goal is to compromise a bank account. Okay, then there are several ways. Okay, the first one is try to compromise user credential. So usually in the security area, we use the compromise means we attack the target successfully. Okay, so user credential compromise means we can be successful to get the user credential. Okay, so here these shaded boxes may represent the event that's compromised that can uh, launch the attack. Okay, and these white box represent one or more specific attack event. Okay, so that it has some leaves. Okay, under this category. Okay, so the first one is user surveillance. Surveillance means, for example, the surveillance camera. Okay, so we may be able to use the camera to steal the user credential. Okay, and we may try to find the handwritten notes. Maybe the user credential has been written in the notes so that we can steal these notes. Okay. Okay, so here I will not go through them one by one. Okay, so this is just for your reference. This is a more complex attack tree, okay, for your reference. So using the attack trees, we can effectively exploit the information available on attack patterns. And we can document security attacks in a structured form. Okay, so here you can see that based on this analysis, we can analyze the attack in a more comprehensive way. Okay, we just list all the possible ways and to see whether the system is vulnerable or not. So based on this analysis, we can guide both the design and the countermeasures. Okay, countermeasures means the solutions. Okay. Okay, so this is just for your reference. Okay, about the computer security strategy, it involves three aspects. The first one is the specification and the policy. What is the security scheme supposed to do? So after analyzing the system based on the attack trees, okay, so we may know what kind of policies we need to have to protect the system. Okay, for example, we want to defend against the unauthorized access of critical files. Okay, so if we want to protect the critical files, this means we need to have access control. Okay, prevent unauthorized people to accessing the critical files. Okay, so this would be the policy, the access control against unauthorized people. And implementation, how does it do it? For the implementation, we need to consider the trade-off. Okay, it should not affect the user behavior. It should not affect the system's resource or computing power. Okay, for example, to launch to carry out the access control, for example, we can use the passwords. Okay, for example, we can set up the two levels of password to provide uh, more secure access control. But these two levels of passwords may uh, may hurt the user experience. Okay, may hurt the user convenience of using this system. Okay, so there are some implementation or design choice for this for the policy. The last one would be the evaluation. How correct the mechanism is, and how assurance the mechanism can provide to secure the system. So this means does this really work based on the evaluation? Okay. So usually how we can evaluate one mechanism, we can just try to use the try to launch uh, potential attacks to see whether the security mechanism can uh, defend against these attacks or not. Moreover, while the security mechanism is launched to defend against this attack, we can also observe how much overhead can be incurred by the security mechanism. Okay, and moreover, in the research, in the computer security area, we also have some formal models which have been proposed to analyze the security assurance of the proposed security design and the implementation. Okay. Okay, security policy. We can have a formal statement of rules and the practices. For example, we specify how a system provides security service to protect critical system resources. Okay, so we can refer to IFC 4949. Okay, there are some formal statements of rules you can refer to. And security managers need to consider the following, at least the following, maybe more. Okay, so the first is what the assets are going to be protected and the vulnerabilities of the system. So how to know the vulnerabilities of the system? We need to, for example, we need to use the attack trees, and we need to analyze the attack surfaces of the system. And then the next one is the potential threat and the likelihood of attacks. Okay, so this is based on the attack trees. And we also need to consider the trade-off. Okay, easy of use versus security. For example, if we set up two passwords, then people, it may be difficult for people to remember two passwords. Okay, maybe we try to set up the policy. For example, this password need to have needs to have at least 15 digits. and it should be a combination of the number of special characters and alphabet. But although it can the a secure password can be created, but actually it hurts the user convenience because it would be difficult for user to remember. Then users will usually keep resetting the passwords. Okay, so this is kind of example. We need to think about the trade-off between easy of use versus security. And next is the cost of security versus of a cost of failure and the recovery. For example, when an attack happens, but it does not create too much cost, or it does not create too much cost to the system, then actually we do not need to set up the security. We just, for example, we just need to, for example, reboot the system. Okay, but if the cost of the failure and the recovery is high, then it is worthy of deploying the security mechanism. Okay, so this is the trade-off need to be thought about by the administrator and the security manager. Okay, so security policy are based on what we just talked about the trade-off. Actually, it is a business decision because maybe the company does not have the enough resource or money to deploy the security mechanism. Okay, then they do not need to do it. Then it can be also influenced by legal requirement. For example, the U.S. government are required to deploy some security mechanism uh, uh, proposed by the government. Okay. Okay, so next is the security implementation and assurance. So usually security implementation, you can consider 4 ways. Actually, it always work for all the systems and the software. So you need to think about from these 4 dimensions. The first one is prevention. The first thing we think about how we can prevent all the attacks. But usually the security mechanisms are not perfect. So we also need to think about when the security mechanisms are broken or bypassed, then how we can detect the attacks. Okay, so next is the detection. So once the attacks are detected, then we need to think about how we can respond to the attack. Okay, for example, once the attack is detected, then one response is to reboot the system or try to quarantine the software which has been compromised. Okay, so you can define or you can design a set of uh, mechanism which respond to the attack. Okay, and last one is recovery because we may not be able to detect the attack right away once the attack is launched. So maybe the attack has been running for a while, for a day or several days. So some damage has been caused in the system. So we also need one mechanism which can recover the damage. Okay. Okay. So basically, we need to have these 4 dimensions on the security implementation. So assurance, it is related to how confident that the system operates such that the system security policy is enforced. So it can be expressed as a degree of confidence. So it can be uh, done based on some formal models. So here are some references. Okay, so you can check. But in this course, we will not talk about these formal models. Okay, because we already have so many security materials we need to talk about. Okay, so if you are interested in how to do the assurance analysis of one security system, then you can refer to this document. Okay, so for example, for the processes, the assurance of the processes. Okay, so you can check this document. Assurance of the product, then you can check this document. Okay, so this is about the security management. So last one is the evaluation. Is a mean a computer product or system with respect to certain criteria. Okay, for example, this criteria can be related to whether uh, it can be used to defend against some potential attacks. For example, the denial of service or eavesdropping, okay, or man in the middle attack. Okay, so we can examine the product or system based on this criteria. And we also need to check whether we also need to check how much overhead the product uh, may cause. Okay, uh, by using the security this security mechanism. Okay. Okay. So this pretty much about the chapter one. So we just give a concept and an overview about the computer security. Okay. Any questions? Okay. So if not, let's continue on next chapter. So we talk about chapter 7 first because it is related to project 1. Okay. Then after we finish chapter 7, then we will go back to chapter 2. Okay. Okay, so here is the formal definition of the DOS attack. So a DOS is an action that prevents or impairs the authorized use of networks, system, or applications. Okay, so basically it covers these three important resources, entities. Okay, networks, systems, or applications. By exhausting resources such as a CPU, memory, bandwidth, and the disk space. Okay, so usually the DOS attack is to consume all the resources so that we can prevent networks, system, or application uh, uh, from uh, uh, from wrong from authorized usage. Okay. Okay, so here is the outline. First of all, we will talk about some the conventional, traditional DOS attacks. Then we will talk about the flooding attacks. Then DDoS attack and the application-based bandwidth attacks. Then finally, we will talk about the reflector and amplifier attacks. So this is related to project 1. Then we will talk about defenses and responding to a DOS attack. Okay, so about the denial of service attacks, it's compromise. Compromise means attack successfully or hurt availability by hindering or blocking completely the provision of some services. Okay, so the intuition actually uh, you can come up with about uh, the flooding, which is kind of a major denial of service attack tool. For example, we can flood a web server with so many requests, or we can flood the traffic a large number of packets to a specific server so that we can overwhelm the bandwidth of the server so that the server cannot serve other requests. Okay. So the major concept is try to generate a large volume of something, request, packet, traffic, or tasks, okay, to uh, to exhaust the resource. Okay. So nowadays, actually, because nowadays, as you know, the bandwidth is very high for all the machines and the networks. So it may be difficult for a single machine to launch the DOS attack. So nowadays, the DOS attack can be successful. Actually, most of them belong to the distributed denial of service attacks. So distributed means we launch this attack from different from many machines. So we try to aggregate the resource and the traffic from these machines to attack a single server or a single target. Okay, so that we can overwhelm the resource of that target. So this is because this is due to the internet bandwidth growth. So in 2002, actually if you want to overwhelm one web server, then you need to generate more than 400 megabit per second bandwidth or traffic so that you can attack that server successfully. But in 2010, you need to generate more than 100 gigabit per second. Okay, so this number is for some public web server, for example, the Google, Facebook, or other kind of services. Okay, in 2013, you need to generate more than 300 gigabit per second. Okay, so this is for the case of this company, which is called Spam Host. So this is an international organization to track email spammers and spam related activity. Okay. Okay, so this is a company for this the anti-spam service. Okay, so nowadays you need to generate at least 50 gigabit per second so that you can exceed the bandwidth capacity of any target. Okay, so here you can see this is very high. For example, for our school, our campus, or for our own home networks, actually it is very difficult to generate such large number of bandwidth. So if we want to if we want to generate such large number, we need to aggregate the bandwidth from many machines. Okay, so this attack is called distributed denial of service. Okay, so one thing to note that to successfully attack the server in terms of denial of service, actually, it is not if the server becomes slower due to the DOS attack, it is also considered as DOS because uh, we hurt its availability. The denial of service does not mean that we need to shut down the web server. If we can make this web server respond more slowly, then it can also be considered a successful attack. Okay. Okay, so there are three categories of resources as we just mentioned from the formal statement about denial of service. The first one is the network bandwidth. Okay, so we try to uh, overwhelm the capacity of the network links. Okay, so basically it relates to the capacity of network links connected to a server to the internet. So for most organizations, this is their connection to their internet service provider, ISP. So it is like the Zhonghua Telecom for our home network. So if a attacker can generate a large number of traffic to your machines at home, then actually it may try to you may suffer from the denial service. But because all of us are not important persons, so we will not suffer from the attack, this kind of attack. So system resource, actually it is related to, for example, the disk, memory, or CPU. So attackers can overload or crash the network handling software. Okay, network handling software means, for example, the TCP protocol stack. Okay, so later on, we will introduce, for example, we can generate a lot of SYN packets so that the TCP server is not able to accept more requests, so that it suffer from the denial service. Okay. So application resources. So it typically involves a large number of valid requests, each of which consume significant resources. So application means, for example, it is just a web server, then we can generate a lot of requests, HTTP requests. Or it is a SIP server, we can generate a lot of SIP requests. Okay, just try to make the application too busy to accept more requests. Okay, so it can limit the ability of the server to respond to requests from other users. Okay. Okay, so here is an example about the DOS attack on network bandwidth. So the width of the line represent the volume of the bandwidth. Okay, so here these represent this large company has a large bandwidth, large network bandwidth, and this small width means this company only have a small network bandwidth. Okay. So this figure just show you that actually if we want to attack this company successfully, then we can launch attack from this large company because this large company can generate a large volume of bandwidth. But these companies are not able to attack this large company or medium company because the bandwidth actually they are much smaller than these two. Okay, so that's the traffic generated by these two companies will be constrained by the outgoing bandwidth provided by the ISP. Okay. Okay, so next let's introduce the classical DOS attack. The first is the pin flooding attack. So the traffic initially for the pin actually it relies on ICMP packet. Okay, so I think most of you may have been familiar with pin because usually when we want to know whether one machine can be accessed or not, then we will use the pin to see whether the target machine will reply to this pin or not to identify whether this machine is still online. Okay, so pin actually relies on ICMP echo request and the response packet. So we can generate a lot of pin. And the goal is to overwhelm the capacity of network connection to the target organization. And traffic can be handled by higher capacity links on the path, but packets are discarded as capacity decreases. Okay. So if we want to use the pin, for example, we try to pin the target machine from our machine, then there are two disadvantages from the attack's perspective. The first is that the source of the attack is clearly identified because we just use the pin. Okay, so the target machine can easily trace back to the attacker based on the source IP address. Okay, so this is the first advantage. The second advantage is that attack reflection at the source system. When we try to use the pin to pin the target machine, we will also receive the response from the target machine. Then our bandwidth will be also consumed very quickly because we send out the pin echo request and we will also receive a response. So actually, our network bandwidth will be consumed in the volume as much as the target machine. Okay, so network band performance will be noticeably affected. So in order to improve this attack, so this is why source address spoofing is proposed to launch the attack. So we can forge the source address. So is it like what you are going to do in the project one? We will use the spoof address in the DNS query, so that the DNS server will send the packets to the target machine. Okay, so we can forge the source address. Then usually we can use the raw socket interface on OS to create the spoof packet. So if you just use the command line on your machines, you are not able to specify the source IP. So you need to use the raw socket interface to do it. So consider the pin flooding attack. The same congestion on target router. Okay, and if we use the spoofed ICMP packets, okay, so the same congestion would happen on the target router. But ICMP echo response packets are no longer reflected back because the response packet will be sent to the machine with the source IP address with spoof on the ICMP echo request packet. And we can also use the randomly spoofed source addresses so that the backscatter traffic would happen. Then the traffic will be sent to many machines. Okay, because we can fill in all the different source addresses. So it is harder to identify the attacking system. The reason is that it cannot use the source address to trace back to the attacker. Okay, then you may wonder why such forgery of source address is allowed. Actually, it can trace back to the story of the development of TCP/IP. So initially, when the TCP/IP was development, actually the designers do not think about the security. It does not design the protocol in a security way because by that time we just want to make the network or make the internet work successfully. We never think about actually the designers never thought about that TCP/IP will become so popular nowadays. Okay, so for the development of TCP/IP, actually, the environment is generally cooperative because two ends just want to send the packets in a reliable way. Okay, so they are cooperative, then they are in a trusting environment. It simply does not include the ability to ensure the valid source address. Okay, so how to address it? If we want to address it, we need to impose the filtering on routers to ensure it. Then it should be as close as to the originating system as possible. For example, the borders of the ISP connections. So here we can go back to the figure to talk about this concept. For example, the source spoofing packets are sent out by this company. Then we need to set up the filtering at this router, so we can know this source source spoofing packets are sent out by this company. So if we set out the filtering, for example, at this router, And actually, we are not able to judge whether the packets are sent out by this company or this company. So we need to set out the filtering mechanism at the border gateway of each network so that it can be effective. Okay. So it has been a long-standing security recommendation. Okay, has been specified by this IFC 2827. However, many ISPs do not implement such filtering. So what will be the reason? Why most ISP do not implement such filtering? Okay, so the reason is that because if we want to deploy the security mechanism, for example, the firewall filtering, uh, pre malware detection or security prevention, all these mechanisms actually will decrease the performance, the network performance, because we need to check each packet, and the bandwidth will decrease. If the bandwidth decreases, that means the revenue will drops for these ISPs. So these ISPs would rather not deploy uh, this kind of security mechanism, because even if the source spoofing packets happen, actually uh, these do not hurt the ISPs. Okay, so they would rather see this kind of source spoofing packets happen, but they will not deploy the filtering to defend against these attacks, because their revenues will be hurt. Okay. Okay, so next, we talk about the SIM flooding attacks. Okay, so here we still use the SIM spoofing so that we can prevent the attackers from being traced back to. So the goal is to attack the ability of a network server to respond to TCP connection requests. So here, let's try to refresh your memory about the TCP connection. So to set up a TCP connection, the client needs to send out the SYN packet to the server. Then the server will reply with the SYN egg. Okay. So basically here you can see they try to synchronize with the sequence number. And different directions have different sequence numbers. Okay. And here the last packet is egg packet. You will send the egg to the server. Okay. So how we can launch these attacks? So here you can see when the server receives this SYN, the server needs to remember this sequence number. Okay, so that once the client reply with this egg, then the server can know actually this egg is related to the SYN received by the server. So once the server receives this SYN, the server need to remember this sequence number. This means the server need to create a memory, need to create a space in the memory to store this sequence number. Okay, so based on this action, actually, you can come up with an attack that we try to generate a large number of SYN packets with different IP addresses. Then the server need to have a lot of spaces to store this sequence number, which have not been egged by this egg packet in the memory. And once the memory is consumed, is exhausted, then the server cannot accept more requests. Okay. So based on the implementation of the TCP server, actually the TCP server uses a table, and the memory of this table is fixed. Okay. So once we can overflow the table, which are used to manage such connections, actually the server would suffer from the denial of service. Okay, so we can use the TCP SYN spoofing attacks. So we generate a very large number of forged connection requests to a server. Okay, for example here. So we only generate a large number of requests. We do not, the attacker does not acknowledge all these connections, so that all this connection information was will always remain in the memory of this table. Okay. So based on these SIM flooding attacks, legitimate users are denied of access. Okay. So here, let's compare with the basic flooding attack. Actually, since here we does not try to overwhelm the bandwidth of the server, we try to exhaust the memory of the server. So we do not need to generate a large number of traffic. So the actual volume of SYN traffic can be relatively low compared with the pin flooding attack. So it just be high enough to keep the non-TCP connection table filled, so that it does not have any more table resource to accept more connections. Okay. Okay, so I think let's stop here. Then we will continue next week. Okay. Thank you.